Ladies and gentlemen, so we combining radicals here. Assume that all variables represent non-negative real numbers. It's always important that you are able to read the instruction to make sure that you're going by what the instruction says, because a lot of times we forget about that. We see the problem and then we dive into it and then we're going to make a mistake, of course, at the end where the instruction is saying something totally different. So non-negative real numbers, all right? So now let's take the first problem here. So the first problem is was negative 2 cube root of 125 a to the third power b to the fourth power plus 3b squared cube root of 8 a to the third power, all right? So I put on the right side over here that nth root of x to the power m is just the same thing as x power m over n, because you can change a radical into an exponential format. So the n, which is the index, becomes the denominator, and then the m, which is the exponent, becomes the top number there for the fraction, okay? So this one becomes an exponent where you have the m over n, which is also here. So you can always interchange the two of them. So that means if you were given this one as, you know, a variable over power, you can always change it into a radical format, all right? So those we're gonna see some of the problems in, you know, different videos, but that would be really interesting to know that, so that can help us here, okay? So we have negative 2 cube root of 125 a to the third power times b to the fourth. First thing, we go with the 125. So 125, how do we break it down into a number such that when you take that number, you multiply that number by itself 3 times, okay? That will give you 125. So by now, if you guys keep working on such problems, you will see that some of these numbers will pop up, you know, many times. You will know them. So once you see them, like 125 cubed of that, you already know that it's going to give you 5, because 5 times 5 is 25, and 25 times 5 is 125. Or somebody can just take the 125, divide that by what? 5, because any number that ends with 5 is divisible by 5. Okay? So you have 125 divided by 5, that will give you 25, and 25 divided by 5 will give you 5. So that means this one is equal to negative 2 is down here. So we still have our cube roots. So this is then 5 to the third power, all right? And then the next move is, when it comes to the a to the third power, the question is, what do we do there? So that's the reason why I put this one here, so you guys can see that as a radical, you can change it into the exponential format. So this one is the same thing as a to the third power over 3, okay? So that's 3 divided by 3, that gives you 1. Or you say 3 divided into 3 is giving you 1 time, okay? So it's going to give us a 1, but at this point, we keep it in here for now, okay? What about the b? The b is going to be cube root of b to the fourth power. How many times 3 can go into 4? It's 1 time, okay? And then what's the remainder? 1, all right? So this one is going to be b then, power 3 times b, all right? Or b1 if you want to, because if you multiply b3 times b1, it's giving you what? b4, okay? So far I'm still taking time with these problems here, okay? So if you want to, you can put the multiplication here and here. If you want to, if you don't want to, you don't have to put it, okay? It doesn't change anything. So now you have plus 3 here, b to the second power, and what's happening in this one here? So we have cube root of 8. So is 8 a cube root, you know, a perfect cube? So that means yes, because it's 2 by 2 by 2, that would gives you 8. 2 times 2 is 4, 4 times 2 is 8. So that means 8 is a perfect cube. So what's going to happen? That will go outside, so that will be 2 outside, or we can keep it like that for now, as we did before. So we have our cube root here, and then this one is 2 to the third power, and then a to the third power, because this one also, 3 can go into 3 1 time, so a to the third power is a perfect cube. Okay, so for now we keep it in there and see how we can simplify them. So once we come back here, So what's coming out and what's staying in? Because at the end of the day, when you simplify radicals, it's all about what are you breaking down? What is coming outside the radical and what is staying under the radical? Sometimes nothing staying inside. So in this case, what is coming out? So we have 5. So the 3 crossed out. So that means 5 has to come out. So it's negative 2 times 5. Okay? What else is coming out? The A3, 3 here. So A also comes out. And then for B, B3 and 3, B also comes out. And what is staying in? Cube root of B power 1 or just B. Okay? So this one, which is not a perfect square, stays under the radical. The perfect cubes will go outside, and then the ones who are not perfect cube will stay under the radical. That's how it works. Okay? And then plus then, so you have 3, and what is coming out in these cases here? So we have B to the second power times, then 2 to the third. So 3 crosses out, and then you have 2 outside. So multiply by 2. And then when it comes to A3 and 3, so the A also is coming out. So there's nothing left under the radical in this problem there. All right? So then to finish with, negative 2 times 5 is negative 10. And then you have the A and then the B. Then you have cube root of B on this side plus 3. So 3 times 2 is going to give us what? 6. All right? So that'll give us 6A B to the second power. And this is going to be your final answer because you are not able to combine these two, expressions there or 2 terms there. There's no way you're going to combine this one with that. Okay? So this is going to be your final answer. So again, we're taking time so that we can learn, understand what we're doing, and then later on, we can go faster. All right? So let's see what's happening here. But second question. So we have 3A cube root also again over here of A to the 4th power times B. So what's going to happen to the A to the 4th power? Because again, we're doing 4 over 3. Like if we apply, this statement here. So this is 4 over 3. And then 3 goes into 4 one time. And then there's a remainder 1 because 4 minus 3 is going to give you 1. So basically, this is 3A cube here, A to the 3rd again, all right? And then A, 1, because A power 3 times A power 1 gives you A power 4, and then you bring down the B. All right, then minus 2 here, all right? And then cube root of A to the 3rd power, this one is a perfect cube because anytime that you have the same index and then the same power, that is a perfect, whatever it is here. So in this case, it's a perfect cube, all right? So because that's a perfect cube, that one will come out, but we keep it there for now. And then we have our cube root. Then we still have our A3. What about B5? How many times 3 goes into 5? 3 goes into 5 one time. All right? So it's going to be B3. And what's the remainder? 2. So that'll give you B2. Okay? And then we come back here. We have 3. Then what's happening after that? So that would be what? 3 out. So that is A times A. A times A, right? Because the A will come out. And then what also is coming out? Anything else? No. And then the A1 stays under with the B. Are you guys with me? You seeing what we're doing? So the A to the 3rd is a perfect cube because we're dealing with a cube root. So 3 crosses out. And then what crosses out? So what happens? The A stays. So that A is going outside. Okay? Because that's a perfect cube. Then there's another A next to it that will stay under the radical. Okay? Because you cannot simplify that one. And remember, we said that before. Whenever the index is higher than the power, there's nothing you can do about it. You just keep it like that. Nothing to do about it. So this one is going to be B. Then minus 2. And then what's happening after the minus 2? So this also, the A is going to come out, okay? And then 3, 3, the B also is going to come out. And then what's staying in? B to the second power stays in. Now let's do any operation that we can. So A by A is going to give us A squared. So you have AB minus 2AB cube root of, let's don't forget about the cube, okay? You have to be very careful when you're working on these problems, okay? So you don't leave anything out. So can we combine these two together? No, because this is a different term. This is a different term. They do not belong to the same family, so they're not, working, together in this one, okay? So this is going to be your final answer, for this problem here. So take a look at it again, and then again, take your time, go step by step, master it, and then keep moving, all right?